focus on you in the light. It helps me feel my emotions. Why are we at such a distance? Find ourselves so out of frame.
Okay, so now we're into the second part of our study guide, which focuses on finding the equation of the tangent line at a given point. So the first thing we have to do if we want to find the slope, or find the equations, we have to find the slope. So we want to find the derivative of y. So if we define a y prime, this is a classic quotient rule problem because we have a function divided by another function. So we're going to do low d high less high d low, then square the low, and there you go. So low is x squared plus 1. D high, the derivative of the high, d high, is the derivative of 2x minus 4, which is just 2. Okay, less high, d low, the derivative of the low, the derivative of the denominator, is the derivative of x squared plus 1, which is just 2x. Then square the low, and there you go. X squared plus 1 squared. Okay, so we're looking at 1, so we're going to look at y prime plugging in 1. We're going to get 2 times 1 squared plus 1 minus 2 times 1 times 2 times 1 minus 4, and that is all over 1 squared plus 1 squared. So all I did was plug in 1 once I found my derivative using the quotient rule. And now what I'm going to do is I'm just going to simplify. So 1 squared plus 1 is 2. So 2 times 2 is 4. Then we have 2 times negative 2. And then on bottom we're going to have 4. So this is equal to 4 minus 2 times negative 2 over 4. Okay, so 2 times negative 2 is going to be, well, really we have negative 2 times negative 2, right? This is going to be 4 plus 4 overall. Okay, there's a couple ways to get to it. 2 times negative 2 is negative 4, but then we're doing 4 minus negative 4. Either way, it ends up being 4 plus 4, which is 8. So we get 8 over 4, which is equal to 2. So to recap, we did quotient rule to find the derivative. We plugged in 1 to find the slope of the tangent line at 1. So we plugged in 1 to our derivative and got an answer. It's 2. So last step we have y minus y1 equals m times x minus x1. We know m. M is 2. We just found that. Okay, so we also know x1. x1 is x equals 1. It's just 1. So all we need to do is find y1 by plugging x back in. So if we do, if we just plug in 1, we get 2 times 1 minus 4 over 1 squared plus 1. So 2 minus 4 is going to be negative 2. Over 1 plus 1 is 2, so we have negative 1. So this is our y1, whereas x1 is just 1. So our final answer then is y minus, what do we get for y1? We got negative 1, so it's y minus negative 1, which is y plus 1. And then our m value was 2 times, and then we do x minus x1. x1 in this case was 1. So then this is the final equation of our tangent line. If you were to plug in this function to Desmos, in which case you'd have to move the negative 1, or the plus 1 over here and make it negative 1. It'd be 2 times x minus 1 minus 1. If you were to plug that into Desmos, and then if you were to plug our original function into Desmos, this would just be the line that's tangent to the curve of this function at x equals 1.